Today we are looking at Leetcode number 261. It's called Graph Valid Tree. Alright, so let's take a look at the prompt here. Given n nodes labeled from 0 to n-1 and a list of undirected edges, each edge is a pair of nodes. Write a function to check whether these edges make up a valid tree. Okay, so we have example 1, n is 5. The edges are 0 and 1, 0 and 2, 0, 3, 1 and 4. The output is true. Example 2, n is 5. The edges are 0, 1, 1 and 2, 2 and 3, 1, 3, 1, 4. Okay, we have a note here. You can assume that there's no duplicate edges since all edges are undirected, and the same as 1 and 0 thus will not appear together in edges. Okay, so right off the bat, what we got to figure out is, what is a tree? What is the definition of a tree? Okay, and so the definition of a tree is that it is a graph, but it cannot have cycles. The only difference between a tree and a graph is that a tree does not have cycles. So first we have to convert these inputs into a graph. Okay, we can do an adjacency matrix or an adjacency list. I think if we do an adjacency list, we can easily traverse this input and figure out if there's any cycles in the input. So that's number one. Number two is that there cannot be more than one region. Okay, so let's kind of visualize this. If we have 0, let me use a different color here. Okay, if we have 0, and then we have 1, and then we have 2, and 3, and then we have 4 here, this is not a valid tree. Okay, because we do have a tree here, but we cannot have more than one region. So this will not be valid. Likewise, if it was just a connection from this 1 to this 4, this would be a valid tree. Okay, but if we have a connection here between this 2 and 3, then we have a cycle here. And that will not be a valid tree. Okay, so what we want with this, with a valid tree, is no cycles and regions are less than, there cannot be more than one region. So not more than one region. If we can have these two elements checked and the graph has no cycles and there's only one region, then we can assume that our input is indeed a valid tree. Okay, so let's jump into this. And what we want to do here is, right off the bat, when we see this, okay, we're getting a list of edges and an input of n, so we're getting an edge list. We want to just first convert this into an adjacency list. That way we can just easily traverse this and we don't have to think too much about it. Okay, so I'm going to just create a helper function here, build adjacency list that takes in n and the edges. Okay, and now I'm going to actually create my array that I'm going to use that's going to represent the adjacency list. From, and then here we're going to do a length of n, and we're going to set every element in the array in this adjacency list to an empty array, and this is a brand new array that's mapped to its own specific place in memory. Okay, we have length here, and now what we're going to do is just iterate over our edges and we're going to pull out the source and the destination of our edge. So the index 0 is going to be our source and the index of 1 is going to be our destination. We're just pulling those out here as we iterate over these edges right over here. And we're just going to map that to our adjacency list. because this is an undirected graph, we're going to mirror this. So as we push in the destination to the source, we have to mirror it. At the destination, we have to also push in the source here. And then we just go ahead and return our adjacency list. Okay? And so in the first part of this main function, the first thing we're going to do is we're just going to create our adjacency list. Build adjacency list and edges. Now, for this main function, we have to create some variables to keep track of the nodes that we're visiting as we traverse. So we're going to have a visited object, set it to an empty object, and we're going to also have a parent object. We want to keep track of the parents. And then we need a region, and we'll set that to 0. So we want to keep track of everything that we're visiting so we don't visit anything twice, but we also want to keep track of the parent of every node that we're visiting. And the reason we want to do that is going to help us determine whether we have a cross edge. And that's the key to this. We have to figure out, does this graph have a cross edge? If there's a cross edge, that means that there is a cycle. And if you're still unclear about the different edge classifications, I highly suggest reading the chapter on graphs in Introduction to Algorithms. It's that giant book. You can find it online. And there's a section in there for edge classifications. You can have forward edges, backward edges, cross edges, and it's really, really important to know those different edges and how to figure out whether your graph has those or not. Okay, so we'll just create our main loop here. Equals 0. X is less than adjacency list. Vertex plus plus. Okay, and this is all like just basically off a very basic graph traversal template. I'm not doing anything new here, and if you look at a lot of my other videos, I just follow the same template and the same pattern. And it's good to have those in your back pocket, because then when you see these problems, you can really quickly solve them because you don't have to think too much. So here we can check if not visited. Then we want to go ahead and first we want to go ahead and increment the regions, because that means that we have a region. And now we want to check, is there more than one region? Remember, if there's more than one region, then we do not have a tree, and so we want to exit out of this. So we can say if regions is greater than 1, return false. And now we just have to check is, we'll do breadth first search, cycle, vertex, if there's a cycle from this vertex node, that means that we do not have a tree, and we're going to also return false. And then if we make it through this entire loop and there's no cycles and there's only one region, then we can assume that our input is indeed a valid tree. Okay, so now we just have one more function, is we have to create this BFS cycle. And we're just making a slight modification, and we're adding this parent in there. And that's going to help us determine whether we have a cross edge or not. Is BFS cycle. This takes in a node, our adjacency list, visited, and our parent. Okay, now remember, anytime we're dealing with a breadth first search algorithm, we want to use a queue. Okay, so we're going to go ahead and create our queue, and we'll go ahead and set that node, that vertex, as the element in the queue. And now we want to create a while loop, and while we want to keep on iterating over this queue and pulling nodes out of the queue while we have elements in that queue. So we can just do a queue.length. While we have a queue.length, we're going to go ahead and pull out that node. We're going to shift out that node. So we can say cur node. Okay. We want to update our visited. And we'll set that to true. That way we don't repeat visited nodes that we've already been to. And now we want to iterate over all the neighbors. We're doing a breadth first search, so we want to check all the neighbors from that current node. Okay, and now we want to check, have we been to this neighbor before? Now, and we only want to go into this if we have not been into this neighbor. So we check if visited of neighbor. If it's false, that means we have not visited. We want to update visited. Okay, and now we want to update the parent, right? The parent of the neighbor is going to equal the cur node. And then we want to add that neighbor to our queue. Okay, now we need to check, is there a cross edge? Okay, and how do we do that? Well, we have to check, does the neighbor and the parent of the current node, if they do not equal each other, then we can assume that there is a cross edge. So if neighbor does not equal parent of cur node, then we return true. Okay, else we return false. And again, this is the main part of it right here. This lets us know whether we have a cross edge or not. If this is true, then we do have a cross edge, and we want to go ahead and return true. Okay, that means that this BFS does indeed have a cycle. And what I would recommend is that if you're not sure how this works, step through the code. Make a little chart, draw it out each iteration by iteration, use a simple graph like the input, with 3 or 4 nodes, and go through each one to really give yourself an idea of how this line right here works. Okay, so let's go ahead and run this, and we are good. Okay, so that is valid tree. I hope you enjoyed it, and I will see you on the next one.